then thank you really for giving me an opportunity to share here. I thought initially, when I was invited, when we were having this discussion with Ken Davis, I was going to talk about like a global local perspective. And then I went to the climate summit, and then several other things happened. And I thought, you know what, let me focus on the things that we've done, that have done as part of collaborative effort with other people that has a US perspective, a very big US component, but it's not disconnected from what's happening in other places, as you'll see in a moment. If I can bring back this. All right, so I'll give you some contextual background, and really the goal here is just to give you a very big bird's eye view of how the people I collaborate with define sustainability and resilience, and how we situate our work in that context. I'm coming in from a buildings perspective, but I will try to pull out examples, specific examples of places where we intersect with other disciplines, and then also reflect on indigenous and local knowledge, and how this intersects with some of the work that we've done that's at the intersection of construction, material science, and structural engineering, and then reflect a little bit on the social dimensions, and then expand that into the broader system level issues which intersect with several other disciplines. And we don't have enough time to go into all this. So I'll just give you highlights. And if you want more information, please reach out. I'll be happy to have a sit-down coffee chat with you, or share some additional information via emails. And there'll be some concluding remarks as well. So I was trying to find a way of summarizing the global agreements that intersect directly with what we are doing from a building perspective. I'm situated in the College of Engineering as a faculty member, but right now I'm also directing an initiative that's called the Global Building Network. And the goal really is to position Penn State and Penn State allies universities that are partnering with us in these global discussions of how can we decarbonize the building sector. But we want to do that while being mindful that we're also having an increasing number of intersecting and compounding disasters. And thankfully, there are some global agreements that govern that, the Sendai framework. We're also mindful of other agreements such as the Paris Agreement, and they work in a complementary manner. The US Sustainable Development Goals, Paris Agreement. If you look at the language that is in there, the summary in my own words was, basically, how can we promote environmental sustainability and resilience to extreme weather events while also unlocking human health benefits, while also unlocking performance and other social benefits? How can we do this? Is it possible? And we believe that it is possible. If it's possible, why is it not happening? So we'll reflect on that a little bit. Oops, what did I do? Yeah, so if you're a picture person, this is the picture version of it. We have the Sustainable Development Goals, making our cities and human settlements safe, inclusive, resilient, and sustainable. The Sendai framework, which talks about reducing disaster risk reduction, and there are very specific targets. And then the Paris Agreement, limiting global warming to 1.5 to less than 2 degrees, ideally 1.5 below pre-industrial levels, and enhancing resilience and adaptation to climate impacts, aligning financial flows with these objectives. So as I said earlier, the language in all these agreements is very complementary. They talk about the same things, but from a different perspective. And the most important thing is that all the countries that are part of the UN system have embraced this. So we don't have to go out there and come up with our new goals and new targets and sell them out to people. That's one of the benefits of having this, that if you're globally engaged, then you know that if you align yourself with these global agreements, then you can have very productive, mutually beneficial conversations with other researchers and other students in other parts of the world. Actually, I wanted to stop here for a moment because one of the things that happened at the recent climate summit in Dubai, I participated in it, and I'm thankful for that opportunity. And one of the conversations that I found most rewarding was after a panel featuring some young students, young people from different countries, including African countries, and they introduced me to the concept of eco-anxiety. I've read about it, but when you have someone talking about it, it's very different. This young lady from Tanzania gave her own experience with eco-anxiety, and she said after the climate summit in Egypt, and I attended that as well, she got overwhelmed by everything she learned. She got depressed. She went back to Tanzania. She's a young lady in her early 20s. She went back to Tanzania. She suffered clinical depression. She could not eat. For several months, she was unwell. And then she got plugged into this network of climate activists who helped her deal with the depression, the eco-anxiety. And then also they gave her ideas on how to plug into the network of young people who are change makers on the ground. And there were several other examples that I don't have time to get into. But at the end of that session, I stood up and I asked them, how can I help? And I did disclose, I'm a university professor. Is there anything I can do to help? I thought they were going to say, oh yeah, just do what you do. When we need you, we'll call you. To my surprise, they actually looked up and they're like, we're glad you're here and we're glad you asked. And they gave me several things, but I'll highlight three. Number one, they said there's a lot of data that is being thrown out there. And they take, similar to you, they're taking their classes in discipline-centric departments. So they expressed a strong interest in educational and awareness building opportunities that help to connect the pieces. I was like, oh yeah, I'm glad to hear this. We know we are kicking the ball in the right place. Number two, they also said, actually I'll share only two because of time. The last thing they shared was very surprising. In the African countries, similar to the US, many politicians end up appointing university professors to play various roles in the governance of the country and also of the local authorities. So these young people told me, do not accept a presidential appointment. I'm like, oh. Yeah, I'm like, okay, that's one ambition gone. I will never become an ambassador or something like that. Yeah, but then they explain themselves. They say that they are struggling to make sense of a lot of the information that's coming out of organizations that are not neutral. And they see universities and higher educations of learning as places where they can get relatively neutral information. And they're saying we need professors to stick to their profession, because as long as you're in this profession, then we can accept a lot of what you're sharing. So I hope this is true of the crowd here, right? And it's against that backdrop that I'll share some of the things here that from a building's perspective, the numbers don't lie. Yeah. In all the documents that are out there, I extracted these numbers from the International Energy Agency. I quote them a lot. I refer to them a lot in my own work. They identified seven top sectors where decarbonization needs to happen, because these are the top emitters. And surprise, surprise, buildings is one of them. But what actually caught my attention is not just the fact that buildings is there. I wasn't surprised that buildings was one of the sectors that is being identified as being a top emitter that needs to drastically reduce its carbon emissions. In addition to buildings, steel and cement are mentioned as separate standalone activities. Yeah, those are two largely used materials, the main materials in the building sector, whether you're in the US or in a developing country like Kenya, where I was born, or Tanzania. Those are the materials that are predominantly being used, and the numbers are there. You can't argue with the numbers. The current levels of emissions associated with the use of steel, cement, the building sector in general, apart from cement and steel, needs to go down substantially. From a building sector perspective, we are at 5% in terms of the targets that countries have committed to. This includes the US. We are saying all the new buildings in the US need to be decarbonized. I mean, all the buildings that are being put out there, the new ones, they need to be 100% decarbonized by 2030. We are now at 5%. And I could generate a lot of numbers that show that we are nowhere near where we need to be. So the other part of it, we talked about operational energy on the previous slide. And in this slide, I was again citing the two main materials, that the two biggest contributors to emissions in the building sector, steel and cement, yeah, those need to fall by 25% for steel, 20% for concrete. And there are a lot of numbers out there. But I focused on this because irrespective of where one stays, whether you are in the higher income, low income category, there's a lot of steel and concrete that's being used. There's a lot of pressure to decarbonize the building sector through several strategies, including building envelope retrofits. There's a lot of steel and cement that's going to go into that, along with several other materials which are on the list of the high emissions. And then I wanted to share this. 2 summers ago, actually before summer, same time in 2021, I was at a conference where I was talking about the benefits of sustainable building materials. And after the presentation, this lady, her name is Pamela Bosch, she approaches me and she asks me, have you ever spent a night in a house that has been built out of hemp? And I'm like, no. Yeah, I've slept in houses built out of other alternative materials, but not hemp. And then she challenges me. She says, I think you should sleep in one so that you can include this in your presentation. So she invited me to go and spend a couple of days with her in Bellingham. She lives in Washington. That's 2 hours away from Seattle. And I spent the 3 days, 2 nights, 3 days in that house. And some of the things that she wanted me to see and experience and also share by, being there with her, it was, I went during summer, during a very warm day. She didn't have a AC on. Her utility bills for the whole year are similar to my utility bills in one month, like during a good month. Yeah, like I pay $120 in my house, and her utility bills for the whole year are that. And she explained that it's actually not even from the energy use, it's from all the other things that she has running in her house. And then the other benefits that the house had, it was, excuse me, it was also pleasant in terms of the humidity level. So she really wanted me to experience it, but she also wanted to have an honest conversation about how difficult it was for her to get this thing built. Yeah, we do not have enough evidence that will convince the necessary authorities, including building permitting, the bank, the people who you need to get the mortgage from, the insurance companies. She explained to me the journey that she went through, going to public meetings with legislators in the podium, and she's heckling them. That is what it took for her to get this thing up. Yeah, she inherited some money. So when the banking system would not give her money, she ended up using her inheritance. She was like, I'm lucky I had that as a resource. Otherwise, this house wouldn't go up. So we say that we want the building sector to decarbonize, but some of the barriers that we have, even when the knowledge is available, is outside our sector. Some of it is in the hands of insurance companies. Some of the hurdles are in the legislature, the building codes, the building permitting. How do we address this? And that's an ongoing conversation that I'm having with her. But then the other biggest challenge, when we try to promote the use of these materials, we've seen this happening in a lot of the developing countries, but we're also seeing it happening now. One of the biggest problems for non-concrete, non-steel buildings is going to be moisture related. I'm talking about flooding, hurricanes, typhoons. And we're not saying that these materials don't do well. We just need more evidence to convince people that they can work. The reason why Pamela has such a hard time getting her house insured is because of this. The reason why she had a hard time getting mortgage is because people have some skepticism. They believe that these materials are not going to do well. So we're like, okay, let's look into this. And I've spent a big part of my career trying to generate evidence in collaboration with several other people that shows that alternative biomaterials can perform the way we want them to perform when we have a changing climate. I also wanted to share a small story here. The first time I met one of my former high school mates, she was working for Goldman Sachs in London, and then she resigned and went back to Nairobi, Kenya. And she asked me, I'm investing in things like housing for women. And I started to tell her about these alternative building materials that we're into. And she listens to me. And after about 5 minutes, she tells me, you sound very academic. And it wasn't a compliment. So I was like, okay, I think I've just been insulted. So I had to think about other ways of explaining the value of the research that we're doing. And I'm like, okay, I like this type of question because that doesn't sound very academic. How do we live with the impacts of a changing climate? My friend will like that one, Harriet. Yeah. The year I moved to the US, actually I moved to the US in August 2005. And by the end of that month, we had Hurricane Katrina. So for me, coming into my first academic position, wanting to do research in low carbon building materials, that was a wake-up call. Yeah. Florida is known to be like hurricane headquarters central. So promoting this material in that context was going to be a challenge, but I thought we had time. However, when this happened, it was like, okay, we cannot divorce sustainability from resilience. We cannot talk about these low carbon building materials and not look at how well can they perform when we have these extreme weather events. This is also important because we know that there's been cases that did not go very well, e.g. this. Brad Pitt in 2008, 2007, 2008, he showed up after Hurricane Katrina in the 9th Ward in New Orleans. And he says, I want to help, similar to what I was asking, but he has money and he has connection. He said, I want to help. People are not moving back into the poorest part that was affected by Katrina. And he wanted to do something to make a change. And he says, if it's lack of money, I have money and I have friends who have money. If it's a lack of access to technical expertise, I have architects that I can reach out to who are the best in the world. So we can crack the code of adequate, cost-effective housing and not make it work not just for New Orleans, but for the rest of the world. Then what happened? It didn't work. Yeah. The first year, things were not so bad, but by the time they got to year number 10, there had been so many problems. The newer solutions, they were designing and building these houses to the highest sustainability standards. It didn't work. The solution that worked was the one on the right. Like, there were people who were addressing the same problem, but they were borrowing a lot from the local knowledge. Yeah, and we can have discussions at the technical level afterwards if you like about this. But I use this as a way of segueing to what is already known. The IPCC talks about this. They say the impacts of climate change are being perpetuated by colonialism. It's not only a driver, but it's also a perpetuator. They're basically saying a lot of the technologies that we are deploying, and I'm looking at this through the lens of the built environment, they are not learning enough from the local, traditional, indigenous knowledge. This is true in the US and it's true in other places. The picture you're seeing there was taken by an undergraduate researcher who was part of my team a couple of years ago, and she introduced us to this UNESCO World Heritage Site in West Africa. She's from Togo. So they have a plant that produces a fruit. When the fruit is dried and powdered, it functions like a cement. And they use this as a binder and a finish. So this is knowledge that is there. Yeah, I thought of this also when I was reflecting on the New Orleans example, because during my first visit to New Orleans, I learned something new that is related to my profession again. There were some carpenters who came to New Orleans, to Louisiana, during the slave trade eras because of their knowledge. They had mastered the art and skill of erecting or assembling joinery for the swampy conditions in New Orleans, in places like New Orleans, where you can't use wood for joinery. They had mastered this art. Yeah, so there's also something there about this global mobility and circulation of knowledge, that there are certain things which we can learn from the US that are good for the rest of the world, but there are also things that the rest of the world can teach the US for sure. We are not doing enough of that. I say this confidently because of the position that I occupy right now, trying to build the global building network. There is not enough two-way exchange of knowledge from the US to the rest of the world and the rest of the world to the US. There's more that needs to happen, especially for the for the low-income populations. And then the other things that we know, I have spent a lot of my career from a material and engineering perspective, material science and engineering perspective, focusing on earth and masonry. This is also knowledge that has been in the country. It's been in the US for centuries. There are examples of buildings that are in place, e.g. this particular one that I'm referencing here, Tao Pueblo, that were constructed somewhere between the 10th and 14th century that are still standing. Yeah, and they are made out of earth and masonry, and we can learn from this. And this can actually help reduce the problems we're having with heat stress. Yeah, some of the problems can be addressed using, a lot of the problems can be addressed using air conditioning. But what we are learning, what people already know, is that when you introduce air conditioning to the low-income bracket, people who are already experiencing energy burden, this is just going to compound them. So we need to be thinking about alternatives. No, I'm not just promoting this material, but all these other materials, hempcrete, materials that are known to reduce heat gain. Yeah, it's not just new knowledge. There is traditional ancient knowledge that we can learn from and incorporate into our solutions. And yeah, so the biggest threat, as I said, for the places where we've worked has been resisting hurricane, wind loads, flooding, that kind of thing. And I'm not the only one who has generated evidence in this area. There are several other people. There was a conference that I chaired in 2019. There's an entire book of proceedings that I'm willing to share with anybody who wants, that looks at examples from different places in the world where people are using non-conventional building material to address different things, including the need for resilience. So we have this data. We need more because we're not going to get to the scale that we want if we don't have more evidence, but the evidence is there. We can make this work. We can produce a lot of, we can address some of the production related issues through collaborating with people in mechanical science. There are problems about building codes that I've talked about already. And we have strategies for addressing this from a technical perspective. Scale and speed of production. So there was a time when I decided to go and immerse myself in the life of masons. What do they do? Because we were saying, our analysis had shown that there were so many things which were going wrong because of the problems with assembly. And there were also some issues that we had observed that this was in the global south context in Kenya and Tanzania. We had seen, I think that was in Kenya actually, that there's a project where people invested their equity, sweat labor, as a form of payment in the hope that this is going to offset the cost of ownership. And at the end of the day, that did not happen. Yeah, so I wanted to know, how hard can it be to erect a wall, right? So I went and did this talk, and the conclusion, it's very hard. Yeah, because we heard from the perspective of the person who was delivering the solution that they started off with this idea of sweat equity, but at the end of the day, they had to hire a lot of skilled workers. Yeah, masonry is a skill and an art. You cannot, go to any part of the world and 1 week you have expert masons from the scratch. They didn't know how to do anything. So that was an eye-opening experience, and we've invested some of the research in addressing this. But here, before I go into the machine, we've looked at how we can use cold sintering. Initially, we were thinking about, we had this idea and vision. We need to eliminate fired bricks. We need to find a way of eliminating fired bricks. And then we realized, actually, no, there are things which we can learn from the process of that they're using to deliver fired bricks at scale. There are so many things wrong with the brick production process, largely outside the US. In the US, they have transitioned to a more efficient process. It's not perfect. I could still poke holes and identify some areas where decarbonization targets are not being met because of the process. But to a large extent, the US is not the biggest problem. The biggest problem is the rest of the world. Why should we care about this? Surprise, surprise. There's still a huge number of bricks that are being imported into the US. So it matters where they come from. So we've tried to look at processes that can compete with brick in terms of having the performance of a fired brick, but at a much lower temperature. This is still early stage research, but we are excited about it. That we are at the point where the biggest question is scaling. How do we go from the size of a cell phone to the size of a real size brick? Yeah, and then we also have, there's a student I'm co-chairing with Marcus in the School of Architecture. I'm glad and thankful that Marcus invited me into this. She's looking at the automated building machine, and she's doing this as part of her PhD thesis. There's a paper she's published that I'm willing to, that we can share with you as well. And I was very happy when they invited me to be part of this journey in 2018, 2019, I believe, because the application domain included a focus on accessible and affordable solutions, creating this machine that can help to deliver a process for people to do DIY type of construction in the affordable low-income market, low housing bracket housing market. She has a working machine. It's still a prototype. It doesn't do everything we want it to do, but it's a very, very big first step. And we want to encourage more people to be thinking about this sort of places where you can plug in. Okay, so I'm going to move a bit faster and go into the social dimensions as we look at them. So there's, in the middle of the pandemic, I had planned, before the pandemic in 2020, I had planned to do a lot of things, but problem, a lot of them required me to travel overseas. And then when the pandemic happened, I couldn't travel. And yeah, meanwhile, there were all these reports and roadmaps that were, painting a very dark picture, like, things are going to be horribly wrong and all that kind of thing. And I channeled my frustrations into writing a proposal. And Thankfully, it got funded, and I'm very happy that this got funded because it's stretching me out of my comfort zone. I basically said the hard engineered approach that we've been using, even though it has a lot of value, it's not enough to get us where we need to get to. So I was redesigning my entire research approach and saying, as part of this project, we are going to be developing new research methodologies that will help us balance the hard engineered perspective with everything else that's not part of laboratory testing, crashing, making prototypes, etc. And the deployment context was Pennsylvania because I couldn't travel, right? So we are learning a lot of things. We're still analyzing the data. We've done focus group discussions. We have done surveys, collected data from about 554 households, and we're still analyzing that data because remember I said part of the process was developing this methodology that includes so many things that I didn't even know how to do before this. But some of the surprising things, just to share, some of the surprising things that we are learning, there are some assumptions that are being made. For example, that people in the low-income housing domain do not have enough awareness of renewable energy technologies. That's not true. Yeah. In all the places where we've had these focus group discussions, they were aware. And they told us a lot of information that, according to theory, they were not supposed to know. And the reason why they couldn't get those things installed was mostly lack of money. It's not because they don't know that this is of value. And then the second reason, number one reason, financial. Second reason, which is connected to the first reason, is many of them are tenants. And they say, like, if they push their landlords into installing anything to improve the housing stock, their rent is going to go up. Right. So we've had a lot of those types of discussions. And some other things which we are learning from these discussions. In one session, one lady was sharing how her mother, who's in her late 90s, during the summer managed to accumulate quite a significant amount of money, of debt, because of her utility, because of heat of cooling during the very hot days. And the questions that they were asking were not about, we don't know that there is help out there, but they're saying the help that is there is not, it's like generic. They are not taking some factors into consideration. Like if it's according to the income bracket, if say it stops at 50,000, if you make 50,001 cent, you're out, right? It doesn't take into consideration other things. And during those discussions, we were very glad that there were people in the room who were saying, oh yeah, we know how to help. We know how to help you navigate these hurdles. See us after this and we'll talk about it. And there are several other things that I could go deeper into. But the idea, we want to develop this framework that looks at all this social, human, natural capital as a way of enhancing resilience, focusing largely on extreme heat within the Pennsylvania context. And then I wanted to also just flag up something that was part of the reading that they shared with you. In 2018, I was invited to join an initiative that was being stood up by the NAACP. And to be honest, when the invitation came to me initially, I was like, no, thank you. No, yeah, because I know the NAACP from a civil rights perspective. And I'm like, I don't do that, right? I don't go to the street. I don't organize. That was a misconception. They do a lot more. I now know better. And I'm glad I gave this lady a chance. I told her that, are you sure you want me to be part of this conversation? And we had a very good discussion. And I realized, you know what? I didn't have a good understanding of the problem and how the technical knowledge that people from my community can bring in can be of value and help. And I'm glad they invited me. From day one, what I noticed consistently that from day one, when we had the first workshop in Pittsburgh to when we published that book that was in the readings, the community members repeatedly told us their number one problem is they are not being invited to co-lead these initiatives. They want to be at the table as part of the design process. They want to be included every step of the way as co-leaders. Yeah, and they pointed out also, places where technical knowledge can be plugged in, but then they're saying a lot of the efforts that are being implemented do not work or they do not scale because they are not being asked to bring their knowledge, their lived experiences. And they gave us specific examples of, as I said, of ways we can come in. They were talking about, yes, there are programs out there that can help you get knowledge and get certified as a lead professional, for example. And they explained, if you don't have the knowledge, the domain expertise and knowledge, you are most likely not going to pass during the first attempt. One person basically said it took him 4 attempts to get the certification, and that cost a lot of money. And then there were conversations where they were asking, do I need to get certification to get the knowledge? Can I get the knowledge just for the sake of getting the knowledge because I want to apply it in my community? And if that's my need and my interest, where do I go for that? So we ended up publishing these guidelines, which, as I said initially, I thought I was going to come in as a very strong technical content provider, but then they humbled us and they told us, no, the process is not right. So it emphasizes a lot on the process, how we enter into the community, how we engage with them, how we get them to feel empowered to articulate what they already know, which will gel very well with what we know. Moving on a little bit. Yeah, and then this was at one of the tables. I think you can even see a spoon. That's why it's at that angle. It was a little bit hard to take the whole view. But one of the things I wanted to zoom in here, they pointed out that affordable housing for the low-income populations, which are largely dominated by people of color, the Black and Hispanic etc., affordable housing is a priority area of need because it connects to so many other things. It connects to access to jobs, access to education, but there are things which we can do from a building perspective which they care about, e.g. health. I knew about asthma before joining this community, but some new things which I've gotten introduced to and I'm embracing as part of what I'm doing in collaboration with others is accessibility, hypertension, cancer. And I remember going into this journey of trying to find that connection with cancer. I was very curious intellectually. I wanted to know, is there a place where a focus on building envelope materials can help address this issue? And the answer is yes. Yeah, and there's a lot more information out there that shows how the built environment in very many different ways can help to address health concerns that the community members have already said are a priority because they are dealing with them. Yeah, some of them are at the scale of the house, others are at the scale of location-related things, urban design things, transportation, public services, land use, green spaces, accessibility, but it's in connection, that interconnection with housing. Yeah, when I started this journey at the University of Florida as an assistant professor, I was looking at housing as a house. I was looking at it as a building envelope, the walls, the roof, the windows, etc. But going through this whole journey, I'm able now to look at it as the walls, the windows, and the roof are good enough, but they don't sit in a vacuum. Yeah, the conversation has to include all the things that the community members care about. And then, yeah, drilling down, yeah, I found a lot of information, things which we can influence, in part by focusing on materials that are locally sourced. A lot of the things which are not locally sourced rely on products such as plastics, which have PVC, etc., specialty chemicals, paintings. Some of the materials that we are researching that are not the conventional ones, they do not require finishing. Yeah, you can build up your house, your wall, and you leave it the way it is if you do it correctly. There are some problems related to the complex landscape. What we mean by this is you have the material that is being extracted from the ground, and many times it passes through several stages of processing before it's in the final product. So even when people are being told, declare, to what extent is your material sustainable? Is it ecologically sustainable, good for human health? We know that this is the right thing to do, but that information is not easily accessible. Sometimes it's not available at all. Yeah, so I've talked about this already. There's this data challenge that a lot of the things that determine the health, the environmental and human health of the materials, products, and technologies that end up in the building that now we know community members are telling us ultimately can contribute to various health risks, including asthma, cancer, etc. We do not have easy access to that information because they are not within our sphere of influence. Sometimes the information is actually because it's not easily accessible because the material, the source, the original source of material is another country. I want to go quickly into this, just reminding us where we've come from, that my premise is from a global perspective, we need to do these two things concurrently. We need to be anticipating, adapting, and responding to climate risks and shocks. At the same time, We need to be thinking about what is making the climate-related extreme weather events more frequent and more severe in their impacts. It's the emissions. How do we do these two things concurrently? We have a project which is bringing together different countries, including countries along the coast of East Africa, Kenya, Tanzania, Mozambique, and US, Florida, and also Pennsylvania, where we are learning a lot of things through collaborating with people in geography, urban planning, built environment disciplines like architecture, engineering, construction. And in the convening events that we've had, this one was had in Dar es Salaam, they say the same message. They are talking about nature-based systems. In Kiswahili, they talk about uota wa asili. So, and I like that actually, because if you translate it literally to be like the original, the original landscape that was in the place, learning from nature, learning from nature-based system is a big thing that comes up. And the people you're seeing in this picture, I put this picture here because they're from 3 different professions. We have an engineer, an urban planner, and we have an architect. And this is in Kiswahili, so you can't read it. There was a lot of similarities in what they were saying in terms of reducing the urban risks. Some of the perspectives that were brought into the room by people who were representing community stakeholders, they were talking about crime as a risk factor that is not often considered when a lot of these solutions are being developed. And crime is a problem in low-income neighborhoods in Philadelphia. It's a problem in Kenya, Nairobi. Yeah, so we don't think about these things, but the people who are in those houses, in those vulnerable houses, are saying this should be part of the conversation, because from their perspective, the risk thing is not like one problem, it's all their problems. In 2021, I think 10 months after the pandemic, that's when we had this event. And I remember having a conversation with a taxi driver. We were asking him why they're refusing to wear masks. This was in Tanzania. And we expected him to give us an answer like COVID doesn't exist. To our surprise, his answer was, COVID is not our problem. COVID is your problem. The people with money who are moving around, that was us. We're flying around from one country to another. Like, that's a problem for you. But then he says, we have problems, but our number one problem in terms of the diseases that are causing fatality is malaria. Right? And we know that malaria is connected to, this is in an urban setting, malaria in Dar es Salaam. Dar es Salaam is the biggest city in East Africa. So we're talking about a problem which, when I was growing up, we knew that there were pockets of places which had malaria in East Africa, in Kenya, Tanzania, but now it's spreading and becoming a big problem in the urban areas, and the built environment is a big contributor to that, because it's contributing to land use change. People are having their houses situated in places that are high risk because of land use change and several other things. And we are actually in the process of writing a proposal where we are looking at how these risks, which used to be pockets in these places that have not eradicated malaria, are spreading risks into the US and other places. We know that there were cases of malaria that were reported last year in some parts of the US. And one of our friends who's a medical doctor practicing in an African country was saying, I have physically seen mosquitoes boarding the plane with people in West Africa in a non-stop flight to the US. So I enjoy participating in these conversations where we give people these multi-stakeholder opportunities to engage, because you learn something new every single time. Then the things that, now beginning to wrap up, the thing that now stepping back and reflecting on what we've done during this entire time, the biggest missing piece, and I see where a researcher like myself in the built environment can make a big contribution working in harmony with others, is reflecting on the interlinkages, the interdependencies, the core benefits, and the potential for unintended consequences. Let's go back to the example of the malaria in East Africa or West Africa. There are some interventions that are being implemented from a disciplinary perspective by public health people largely, and they are doing things such as sealing the openings. The first time I had this 10 years ago, I was horrified. I'm like, why would you do that? And they're asking me, why would you not do that? And I told them, because if you succeed in doing this in a hot and humid context, these people don't have air conditioning. Yeah, you are trying to keep the mosquitoes out, but if you succeed in doing what you're trying to do, they are going to go out because it's too hot for them inside, the human being. So they'll end up being bitten by the same mosquitoes that you're trying to protect them from. And there are several other examples where, interventions which are intended to solve one problem end up compounding another problem. Yeah, I can talk about the same problem of sealing the vents from asthma perspective or other respiratory tract perspective. So we really need to be thinking, especially if you're proposing a solution to a problem, you need to step back a little bit and think about the potential for unintended consequences. We also need to be thinking about the legacy system. There are certain things that are in place in the community. There are certain things that are the way they are because of the legacy systems. And if we do not address those, we are going to end up just putting a Band-Aid on the problem. That is not solving the problem. A lot of the things that went into the guideline that was published under the sponsorship of the NAACP, they talked a lot about addressing these legacy issues. The strengths of the existing interdependencies, emergence, things which can emerge because of the new variable that you're introducing into the equation, dynamics, causal feedback loops, etc. I have a diagram that will make this easier. So I came up with that. Yeah, I thought that it was important that before we push, for example, the low carbon building material, we need to stop for a moment and think about the context where this is being introduced in light of these interdependencies, the linkages, interlinkages, and potential for potential unintended consequences. And in this diagram, I will explain the terms later on. I did this from a material use perspective, but we can easily do it based on something different. So I'll describe them using this example. As a driver, let's think about it. We are promoting solar panels as one of the ways of decarbonizing the built environment. Very good idea. Problem number one, the solar panels in the world are relying heavily on cobalt and copper that is being produced in the Democratic Republic of Congo. 70% of the cobalt that is in the world market is coming from Congo. We don't think about this. If we succeed in putting solar panels on all the houses in the US, how much problems will we create potentially in Congo? We don't think about that. There's also environmental degradation that's happening in Democratic Republic of Congo. And this is a place where we also have forests that are part of the ecosystem that can modify the climate of the world. We don't think about that. We should be thinking about that. There's a social dimension to it. There are people who are part of that supply chain on the ground, who are part of what they are calling the modern slavery, who are being impacted by modern slavery. Yeah, so we could do this with several other materials. I talked already about bricks. We have bricks which are being imported into the US. We could map this using drivers. Yeah, we could use insulation as another example. Yeah, for our building envelope retrofits, we are pushing for more insulation. Yeah, but when you start looking at the supply chain for insulation, you find that there are several other social problems that are connected with insulation. Even right here in the US, the plants where the insulation is being produced are normally located near people of color who have historically been disadvantaged by manufacturing plants generating pollution that is impacting their health directly, right? So we really need to step back before we push the solutions and start thinking about where is the potential, where are the interdependencies, where are the interlinkages, and where is the potential for unintended consequences which may not be right. Yeah, so I end mine by saying the response is really to try to push for the use of locally sourced materials. We need to try to innovate. Yeah, we want to use the solar panels for sure, but we also want to try to minimize the amount of cooling, the amount of heating that is required by using these locally resourced materials that learn from indigenous knowledge as a way of making sure that we minimize the adverse impacts as possible. Yeah, then this is just the final, I think it's a final slide, I hope, no, maybe the second last slide, that if the goal is really to try to make the world less risky going forward, because the emission reduction problem is in part because emissions are directly linked to climate change related events. Yeah, we need to have a way of generating data that can help us to project and understand that if we do X, yeah, is this going to make the world less risky or more risky? And this should also be the basis upon which resource allocation is done. Then in conclusion, I think going through this journey, I moved to Penn State in 2016, as you heard, and I remember when I was having those discussions with the people who ended up being my department chairs, I came here as a joint hire, engineering design and architectural engineering. My to-go person for references, his first objection was, you don't do engineering design. And I'm like, yes, I do. And then he asked me to define engineering design. So I told him, the way I define it is that this is a way to look at the broader systemic issues that can affect any technology, whether a process or a product that you're pushing out there. They hired me, so I think my definition worked. Yeah, but if we want to define it another way, it's like thinking about these solutions that are targeting addressing lack of resilience in our built environment, addressing problems of high emissions. There's a technical component to it, and that is important. That is never going to stop being important. But the technical component needs also to take into account that there are some broader issues in the system that are best framed as an adaptive challenge. And I put here what I thought was a very I found it easy to get my head around this using this table here. Technical problem, that the problem is known, it's easy to identify, and often recognizable based on experience. I have people in my non-conventional building materials world, the answer to every problem is bamboo. Right. And I could tell pros and cons. There are very many benefits of bamboo, but there are also many disadvantages. Depending on the context, the list of disadvantages would even be higher, but they don't see it that way. The problem, if you frame it as an adaptive challenge, the problem is often unknown and hard to identify, and is tied to deeper patterns and dynamics, and it requires learning. The emphasis in learning, yeah, embracing new knowledge, being intellectually curious. Technical problems, the solution is based on experience and expertise. Adaptive challenges, the solution is unknown, it requires learning. The locus of the responsibility for a technical challenge is with the experts and authorities. And we already know from a lot of the work that we're doing that has community engagement at its heart, this does not work for them at all. On the other hand, if we framed our issues as an adaptive challenge, the responsibility is with those who are affected by the challenge. They become the stakeholders, and this includes the authorities. Technical challenges, the obstacles are usually resource limited, e.g. time and money. So think of Brad Pitt and his community of experts from our world, and some of them who have money. They thought they were looking at a technical problem when they came up with the make it right solution. It ended up being an adaptive challenge. The obstacles were less tangible: hearts, relationship, minds, values, loyalties, and relationships. Those had to be factored in. They had to connect with the local ecosystem to understand the local challenges of deploying modern technologies or imported technologies in that context. So with that, I will leave you and invite questions. How can we approach adaptive problems from the Brad Pitt story? So everything that my collaborators and I have done, we've tried to understand the context and the story of the place. I learn a lot by looking at the historic buildings. I've done this in Florida, like just go on a tour of the old buildings that are from, like, I don't know, 4 centuries ago, 5 centuries ago, and trying to learn from them, like what is still standing, what is in place, and how can we embrace this as a starting point for whatever we're proposing as a solution. We've done this along the coast of East Africa. There is a rich history in many of those towns of buildings that were left in place from the 15th, 16th century when the first Portuguese were looking for alternative route to India, for example. So I'm a big proponent from, if there are older buildings in place, learn from them. For the New Orleans case study, I said, during my first visit, I got very lucky that I went to a building, a former plantation that had older buildings. And it turns out that we could, the person who was giving the tour didn't know in advance that I was from a built environment perspective. But because I noticed she was knowledgeable, I tried to learn as much as possible from her analysis of the buildings that we're looking at from a building and construction perspective. So I think history is a good resource, either through written history, or if the buildings are in place, learn from them. If they had spent some time understanding the moisture dynamics in a hot and humid context, which is true of not just New Orleans, but even Florida and several other places in the world, they would have known that experimenting with the new building materials in that context is not a good idea. that is an opportunity to partner with the university professors, for example, and get them to run some tests. And university is a safe space to experiment. That is what we do as researchers. And we can give you objective data that shows you the pros and cons of moving in that direction. So I think one of the biggest challenges for sustainability as a movement has been things which have been put out into the market prematurely without learning about the local context. How can these innovative solutions be put in place in an equitable way in existing cities? E.g. in Baltimore, the houses are pretty old, but they don't seem optimal in the way that some of the traditional structures you've learned. So we have a whole community of people who I've worked with previously who do historic preservation. And the truth is there are some structures which are not safe, so they should not be standing. That is the reality. I think the first place for me would be establishing whether or not that structure should be standing or it should be condemned and demolished and start over. And then in many cases, as I said, there are people who do this as part of their profession, and I collaborate with them, historic preservation. I've actually chaired a student who was from that background of historic preservation. There is knowledge that is in place about how to restore a building, a historic building, that can probably help with some of the housing structures in Baltimore. The people who I work with have mostly focused in the flood-prone areas, but I believe there's a lot of knowledge that has been generated as part of the broader community of historic preservation that could lend itself to this. There are some questions in the room. I think you're going to have to come up.
I can run this for.
Thank you. Hi. So as an engineer and a scientist, what do you think is the next step in promoting, I guess, alternative materials being used for building houses? I noticed in the presentation there were some issues with the lack of standardization in these materials. What do you think is the next step towards obtaining that standardization and making it a more popular material?
All right, we had an entire conference last summer about this, and we didn't come up with a solution. But I think part of the problem is, part of the challenge is when you have, we want to encourage people who are not in the low income bracket, because that's where those materials are being used predominantly right now. And we want to encourage people like me and you, who are not in the poor, the lowest social economic status, to start living in buildings that have incorporated some of these materials, like my friend Pamela. Like when you have that, I think more of that, she would be a much stronger advocate than me as a professor, helping people like Pamela deploy houses. And she's actually opened her house as a living museum. You can walk in and see what she does. You can spend a night there if you want. So I think having more of that synergy between researchers, there are people like me, first of all, living in such a house myself, and then secondly, partnering with people like Pamela to get the word out to a big audience. In the meetings and the workshops that we attend, that the common phrase that is used is we are stuck in an echo chamber. we are not, the message is not resonating well with a lot of people because they are not in the forums where we converge, where we see amazing things. I talked about going to this masonry training. That happened in India because the French architect had moved to India. And the entire campus is very fascinating. He lives in a house that's made out of that material. That sends a very strong message to the rest of the community that this leading renowned architect from France is living in this house. So that means it's cool. Yeah, and then I think because I'm originally from Kenya and also have family in Tanzania, I think part of the problem for the rest of the world is they use countries, especially the US, as the standard. So they have, you can debate whether or not there's a building code there, but whatever is done in the US affects what is done in a lot of developing countries. So people like me and you who are here should be aware that whatever I post on Facebook, oh, look at my house, that's going to set the standard for what the young lady in Nairobi, Kenya is aspiring to live at. So just being aware of that influence that there is a social class thing that is associated with what the rest of the world, what the US is doing that impacts what's being done in the rest of the world. I'm trying to think what else. And I think just engaging with policymakers, like Penn State has a forum for evidence to policy. I think that's a big plus, where professors and researchers are selected on a regular basis to work closely with policymakers through engaging in visits, discussions, and preparing policy briefs. So I think they can also play a role. And then the final piece that I will share, participating in the climate summit, I've served on panels that are attended by, have panelists from the medical profession. And I was pleasantly surprised to see that these are also very big advocates, because they can talk about the risks that they are treating in the hospital. Like I had a woman talk about her experience as an emergency room doctor, saying we cannot wait for the air conditioning to get here. Yeah, what else can we do right away? So yeah, those are some of my suggestions. There were other hands.
I know that you spoke about how using local materials or local methods was definitely the best route. But in areas where like a local method hasn't really been prevalent, would having materials like that plant-based cement that you were speaking of be necessarily a better option, considering the carbon emissions used in, say, exporting that into other parts of the, or other parts of the world?
All right, so that's a good question. I will start by actually going back to this picture, and I may not have been very clear in my response, so I will, if I can get it. The house that I shared earlier, it's a hybrid solution. So I don't think we are at the point where we can do 100% locally resourced materials. I'm pushing more for a hybrid. We are looking for substitutes. Let's say we have 100% cement, like the conventional house has 100% amount of cement. I'm looking in my own research and the people I collaborate with, we are trying to find ways of reducing the 100% to 90%, and then 90%, 80, 70. So we're trying to reduce. We are not at the point where we can say zero cement, right? That's not a good idea right now, especially in the hurricane-prone areas, or we can't say zero steel. So again, going back to this, and my slides can be shared, by the way, going back to this example, if you look at it, it has some materials that are the conventional materials. And for where we are right now, with the knowledge that we have right now, that is probably the safest space to situate ourselves. Ben asked a question about building codes, and I think he was asking about the previous question, how do building codes? Yeah, so I think in my original response, I had shared that there are some structures which are not safe to begin with, and the building codes provide a minimum standard for what is safe and what is not safe, and that is the starting point. There are people who are certified as building inspectors who know how to assess historic buildings, and they can make references to the building codes, the minimum provisions of the building codes initially, but that's the minimum, and I'm stressing on minimum. We need to go beyond the minimum, right, to determine whether or not it is safe to restore the structure. Yeah, that's an entire profession that is focusing on historic buildings, and we should leverage their knowledge and expertise as much as possible. So telling you now the other side of the story, my student, John Beatty, who was doing historic preservation, I learned from him because he was involved in some of the restoration work after Hurricane Katrina. I learned from him that people who didn't understand the local system, the local building practices and systems, had gone in and torn off these beams and columns from structures because they thought that they were damaged. And then it turns out that those were older structures that had used timber that was suited for being waterlogged, right? So they didn't need to be taken out. Yeah, so I'm just stressing the point of this is why it is important to engage people who know how buildings fall apart from a historic perspective, and they can align them with the provisions of the building codes. I don't. Oh, there were others. Other than bamboo, what other biomaterials can we use for buildings? Oh, so there are many. I can generate a list for you. there's hempcrete, there's a very long list. I'll generate a list and make sure that is shared. So I'll start with Chris. I like the solutions that were developed from the lower technology areas and that there are multiple access to consider. Are there takeaway messages that can guide us away from the high energy carbon technology? So I'm trying to think. The United Nations Environmental Program recently published a roadmap in partnership with Yale University. And it does talk about building materials and climate change. And I think they did a pretty good job. So I'm only citing this because this is hot off of the press. It was published in December. It was launched at the Climate Summit. That's how I became aware of it. So I would definitely recommend reading it. They try to look at it from so many different perspectives, including health. They bring in the contributions of the building sector to the climate and what can be done to try to address that. And then they also talk about the human health aspects and several other things. I think it's a good starting point for a framework. There was another question in the room.
Yeah, as a young scientist, I don't feel like they stress this enough in obviously your academic course load. But from my experience now trying to get into urban and places where people live, the most important part is getting on the ground and talking to the people there and learning their knowledge and kind of integrating that into whatever you're doing. So it was really cool to see that how important that was in your research directly too. And I was going to ask you, if you're going to go and you were going to take initiative in some place, that was probably what you said would be the first step, is to get there, talk to the people, workshop and kind of do that, correct? Yeah.
Right. And one more online. Okay.
So it's, could you please talk about non-fired earthen masonry, such as compressed earth bricks, and research to make them durable and strong in humid, rainy? This is basically how I got my tenure. So I can talk about it extensively. So what I'm going to do, I'll share an example of a paper. I didn't go in that direction because I knew this was a mixed audience. So I didn't want to over-engineer my presentation. I deliberately downplayed it. But yes, I can talk extensively about it.
I would like to note that the recordings will be posted of the talks, and Esther has provided some literature for reading, and we'll put her slides online, and we'll try to make this obvious to folks. If you just go to the Easy Earth Talks website, hopefully you can find all these materials. If you're in class, you can get it through Canvas page, but not everybody's in class, so we'll try to get it linked up through the Earth Talks Colloquium series site as well. Next week, we have Peter Groffman from the City University of New York and the Carey Institute, who'll be talking about urban ecology. He will not be at Penn State, but you can still come here. And Antonio will be hosting because I'm going to be in Baltimore next week. All right. Thanks, Esther. Let's thank Esther again. Wonderful start for the semester. See you all again soon. Bye-bye.